Alright, given the formula is y prime is equals to y minus t squared plus 1 and y0 equals to 0.5. Use Range-Kutta method with a step size of h equals to 0.5 to estimate an approximate value of the solution at t equals to 0, 0.5, 1, 1.5 and 2.0 respectively. Okay, first, we need to identify the formula for Range-Kutta method, which is this formula. And we need to form a table that contains n, tn and yn, as denoted as first t0 until t4. T0 is equals to 0 as we get from the equation. T0 is equal to 0 and y0 is equals to 0.5. And we need to find all these y1 until y4. Okay, first, we need to adjust the formula to find y1 first. We find y1 using the previous one is t0 and y0. And we replace the n with 0, which is like this. K1n we replace with k10 and all of the above, and we can get y1 equals to y0 plus h over 6 multiply with k10 and 2 k20 plus 2 k30 plus k40. Then to find y1, first we denoted y prime as dy dt as shown like this. Then we need to find fty. Fty given the formula is ft naught and y naught. Ft naught and y naught we can get from the table 0 and 0.5. How we can find f0 0.5 is we know that dy over dt is equals to fty. So we calculate the f0 0.5 using this formula, which is like this. Then we insert the value and we can get the value of dy dt, or k10 is equals to 1.5. Then the next step to find k2 is the same, which is we use this formula and substitute the value into this formula. For h, we know that it's 0.5 and k10 we know that it's 1.5. Then we can get the f is 0.25, 0.875. Then as the same, we substitute the value to the formula, 0.875 minus 0.25 squared plus 1, and we can get the k2 value, which is 1.8125. The next step is the same also for k30, which is we substitute this formula and insert the value that we get, which is h, same 0.5, and k20 we get from the previous calculation, and we can get f 0.25, 0.953125, and we substitute the value to this formula as given, and we can get the k30 value, which is 1.890625. And also the same for k40, we use this equation and substitute the value that we get before, we calculate before, which is k30. We insert the value here and we can get f 0.5, 1.445325, and we substitute the value into the equation of dy dt to get k40, which is 2.1953125. We get all the value of k10 until k40, and lastly, we can find the y1 value and substitute the value that we get from the calculation before as like this. y1 is equals to 0.5 as y0, h 0.5, k10 is 1.5, k20 1.8125, and else. Lastly, we can get y1 value is 1.425130.208. So this is the y1 value, and lastly, we can substitute the value to the table, which is like this. Okay, that's all for y1. I will pass the calculation for y2 until y4 to my friend.
Okay, to find y2, we must to find the k11, k21, k31 and k41. Then we substitute the value of k11, k21, k31 in the equation of y2, which is y1 plus h over 6 times k11 plus 2 times k21 plus 2 times k31 plus k41. Then firstly, we must to find the k11. So we substitute the value of t1 and y1 in the equation of y minus t squared plus 1. So we substitute the value of 0.5 and 1.425130.208 in the equation, and we get the value of k11, which is 2.175130208. And then we find the k21, which is the formula is t1 plus h over 2 y1 plus h over 2 times k11. Then we substitute the value of t1 which is 0.5, and y1 is 1.425, and so on. And k11 we get from previous, which is 2.175, and so on. And then we get the value of t, which is 0.75, and y is 1.9689, and so on. And then we substitute the value of t and y in the equation of y minus t squared plus 1. And then we get the answer of k21, which is 2.40641276. Then we proceed to find the k31, which is the formula is t1 plus h over 2, y1 plus h over 2, k21. So we substitute the value of t1, h, y1, and k21 in the equation, and we get the value of t, which is 0.75, and y is 2.26733, and so on. And then we will substitute the value of t and y in the equation of y minus t squared plus 1, and we get the value of k31, which is 2.4642339, and so on. And then we find the k41, which is the formula is t1 plus h, y1 plus h times k31. So we substitute the value of 0.5 plus 0.5. For y, we substitute the value, which is 1.425, and k31, which is 2.464, and we get t, which is 1.0, and y is 2.6572, and so on. And then we substitute the value of y and t in the equation of y minus t squared plus 1, and we get the answer of k41, which is 2.6572469007. And then the value of k11 is 2.175130208, k21 is 2.40641276, and k31 is 2.4642338, and k41 is 2.6572469008. And we substitute the value in the equation of y2, which is y1 plus h over 6 times k11 plus 2 times k21 plus 2 times k31 plus k41, and we get the answer, which is 2.63960261 for y2. And then we find the y3 using the t2 and y2. So we must to find the k12, k22, k32, and k42 to find the y3. So y3 formula is y2 plus h over 6 times k12 plus 2 times k22 plus 2 times k32 plus k42. Then firstly, same from the we find y2, we must to find the k12. So k12, we substitute the value of t2 and y2 in the equation of y minus t squared plus 1, and we get the answer for k12, which is 2.63960261. And then we find the k22, and we substitute the value of t2, y1, and k12 in the formula, and we get the value of t, which is 1.25, and y is 3.299503326. And we substitute the value of t and y in the equation of y minus t squared plus 1, and we get the answer of k22, which is 2.73003326. And then we proceed to find the k32, which in the formula is t2 and h over 2, y2 plus h over 2 times k22, and we substitute the value of t2 and so on, and we get the value of t, which is 1.25, and y is 3.32 something. And then we substitute the value of t and y in the equation of y minus t squared plus 1, and we get the k32, which is 2.7613539493. And then we find k42, and the formula is t2 plus h, y2 plus h times k31. Substitute the value, and we get the value of t, which is 1.5, and y is 4.0202, and so on. And we get the answer of k42, which is 2.77027940, and so on. And then we substitute the value of k1, k2, k12, k22, k32, and k42 in the equation. We set the value of k12 is 2.63960261, and k22 is 2.7370033326, and k32 is 2.7613539493, and k42 is 2.0702794008, and we substitute in the equation of y3, and y3 which is equals to y2 plus h over 6 times k12 plus 2k22 plus 2 times k32 plus k42, and we get the answer of y3 which is 4.00681897. So I proceed to my friend to find the y4.
So I want to continue for my part, which is to find the value of y4. So if you want to find y4, you must know the value of k13, k23, k33 and k43. For finding the value of y4, we use these four values in the equation of y3 plus h over 6 times k13 plus 2k23 plus 2k33 and k43. So the first step is we find first the value of k13, which is we know the value of t3 and y3 1.5 and 4.00681897. So we substitute these two values in the equation y minus t square plus 1, which is we will get the answer. The answer is 2.75681897. After that, we can find the value of k23, which is the formula is for the value of t3 h over 2, and for the value of y3 is h over 2 times k13. So we substitute with the value 1.5 plus 0.5 over 2, and for the y3 we substitute the value of 4.00681897 plus 0.5 over 2 times 2.756815.7, and then we'll get the answer 1.75 and 4.69602371. And then we substitute these two values in the equation y minus t square plus 1, and then we'll get the answer of 2.6335237. After that, we proceed to the formula with to find k33, which is t3 plus h over 2 and y3 plus h over 2 times k23. And then 1.5 plus 0.5 over 2 to find the value of t3, and then 4.00681897 plus 0.5 over 2 times 2.633523671 to find the value of y3. And then the answer is 1.75 and 4.6651989. And then we substitute these two values in the equation y minus t square plus 1, and then the answer that we get is 2.60269989. And the last one is we want to find the value of k43, which is we use the formula t3 plus h and then y3 plus h times k23. And then we substitute the value into the equation 1.5 plus 0.5 for the value of t3 and 4.00681897 plus 0.5 times 2.60269989 for the value of y3. And then the answer that we get is for t3 is 2.0, and then the value of y3 is 5.30816891 for the value of y3. And then we substitute the answer in the formula, which is y minus t square plus 1, and then we get the answer is 2.30816891. Finally, we get the four values of k13, k23 and k33 and k43. And then when we get all these four values, we can substitute all the values in the formula that y4 is equal to y3 plus h over 6 times k13 plus 2k23 plus 2k33 plus k43. And then we substitute all the values in the formula to get the answer, which is the answer is 5.30160522. And then the answer shown for the value of y4. Thank you. I proceed to my friend.
To prove our calculated value of y0 until y4, we can check using MATLAB. The coding is like this. Then we need to run to check the answer of y0 until y4. From here, we can know if our calculated answer is correct or not. To proceed to the next step.
Okay, next for the percentage error, we have two equations that we need to follow step by step. For the first step, the equation is y equals to t square plus 2t plus 1 minus 0.5 e square t. So we need to change t follow the value that we're giving. We have t is 0. Okay, follow the equation. 0 square plus 2 multiply 0 plus 1 minus 0.5 is square 0. And then we will get 0.5 for the exact number. Next step, by using the equation exact number minus approximate divide exact number and multiply 100. So that we have here is 0.5 and approximate is 0.5, divide 0.5 and multiply to 100, and we will get 0 for the percentage error. This is for the T0. Next, for the T1, we still using the same step and same equation, but we just change the value of T. For the first step, on T1, we change T follow the value that we're giving. T is 0.5 and we will get 1.42563935. Then for the second step, by using the step equation, exact number minus approximate divide exact number and multiply 100, we will get 0.0357% for percentage error. Okay, for the T2, we still using the same equation as step. First step, we will change T to 1.0 and then we will get 2.64085986. Okay, and then for the second step, the number is 2.64085986 minus approximate number 2.63960266 divide 2.64085986, and then we will get 0.0476 for the percentage error.
Saya akan sambung untuk cari percentage error untuk T3 dengan T4. Jadi kita akan pergi ke T3 terlebih dahulu. Untuk cari percentage error ni, kita ada dua step, iaitu step yang pertama, kita akan gantikan nilai T3 ke dalam persamaan Y sama dengan T kuasa 2 tambah 2T tambah 1 tolak 0.5 eksponen T. Nilai 1.5 tu kita akan gantikan ke dalam T. Jadinya persamaan itu akan jadi 1.5 kuasa 2 tambah 2 darab 1.5 tambah 1 tolak 0.5 eksponen 1.5. Jadi jawapannya akan jadi 4.0091556465. Untuk step kedua pula, kita akan masukkan nilai yang kita dapat tadi ke dalam formula percentage error. Untuk formula percentage error, kita akan gunakan formula exact number tolak approximate number bahagi exact number darab dengan 100. Nombor yang kita dapat tadi akan ditolak dengan nilai Y3, iaitu 4.0091556465 tolak dengan 4.006819 dan dibahagi dengan 4.0091556465 dan kita akan darab 100. So jawapan dia akan dapat 0.058278233. Untuk percentage ni kita akan ambil lebih kurang 40-an. So jawapan akhir dia akan jadi 0.0583. Seterusnya, kita akan cari pula nilai percentage error untuk T4. Kita akan gunakan dua step yang sama, iaitu step yang pertama, kita akan gantikan nilai T4 ke dalam persamaan Y sama dengan T kuasa 2 tambah 2T tambah 1 tolak 0.5 eksponen T. Nilai T4 iaitu 2.0 kita akan gantikan ke dalam T di dalam persamaan. So, persamaan itu akan jadi 2.0 kuasa 2 tambah 2 darab 2 tambah 1 tolak 0.5 eksponen 2.0. Dan jawapannya akan dapat 5.30547191. Lepas kita dah dapat nilai tersebut, kita akan masukkan dia ke dalam formula percentage error, iaitu exact number tolak approximate number bahagi exact number darab dengan 100. Jadi jalan kira dia adalah 5.30547191 tolak dengan 5.30160523 bahagi dengan 5.30547191 dan didarab dengan 100. So jawapan akhirnya akan dapat 0.07288173. Dan kita akan ambil 4 saja titik puluhan. So jawapan dia akan jadi 0.0729%.